We're just going to move back into looking at some of the wider Cyclone Gabrielle impacts. So I'm pleased to introduce to you Emily.Lane, who is Principal Scientist in Natural Hazards and Hydrodynamics at Earth Sciences New Zealand, the NIWA group. Emily is leading the flagship program in hazards at Earth Sciences New Zealand, and following Cyclone Gabrielle, you led the extreme weather response. So today, Emily's going to talk to us about understanding the flooding caused by Cyclone Gabrielle. So welcome.
Thank you. I guess not the whole extreme weather response, but we did have a small part of it where we were looking at flooding. And so, yeah, I'm going to be talking about that work, basically sort of understanding the flooding caused by Cyclone Gabrielle and how do I get this? Where do I need to point it? Oh, yep. Yeah, no, there it is. But yeah, we've all sort of seen that picture of it. But just sort of, going big picture for a sort of start, some of the other things around, we had a tropical cyclone and it came down. We also had a marine heat wave at the time, and this is what the temperature looked like. So this is the temperature anomaly. So red or yellow is sort of where it's hotter than it would normally be for that location, and the blue colours is where it's colder. So there was this marine heat wave. That is like 6th of February. If we go forward, that's the 15th of February. And so you can sort of see that whole area down where the tropical cyclone came from, that was where it was getting its energy, keeping its energy up as it came down to New Zealand. And so, the fact that we had this marine heat wave was also sort of something that compounded it meant that it was stronger when it arrived in New Zealand. Another thing that was happening at the time was we had a La Niña weather pattern, and so you can sort of see the actual the anomaly that we had in 2023. We all know it was an insane year for rainfall, and then you've got the La Niña and the El Nino. So to the left is the La Niña, and so you expect more rain in the North Island, especially sort of the north and the east of the North Island under that La Niña. And I mean, the seasonal weather forecast sort of, for December 2022 through to February 2023 was sort of, bringing the risk of occasional heavy rain and flooding. So, La Niña, you do want to worry about it in those sort of situations. Another thing that, and again, a lot of this work is not mine, I'm just sort of the face of it. This is not mine at all, but some of my colleagues did this work sort of looking at the effect of climate change and basically comparing what happened in Cyclone Gabrielle compared with what would have happened without the global warming that we have already experienced. And they basically showed that, it was about 10% more total rainfall and about 20% more intense peak rainfall because of that climate change impact. And that's an open source paper, so if you're interested in it, there's the QR code there, but check it out. But yeah, so how much rain did fall during, sorry, I'm doing a bad job of this. I think there's a bit of a lag. Okay, let's go forwards, and I won't touch it. But so this is my colleague Trevor Carey-Smith sort of put this together, pulling all of the observations that we had and also sort of information from some of our modelling. So it's just trying to get the head around, what actually happened. And so, yeah, I mean, obviously, Northland you saw a lot. There was a reasonable amount in sort of the Coromandel, but obviously sort of Gisborne and Tairāwhiti and Hawkes Bay were the places that really saw the impact, and some of those ones in Hawkes Bay might be even higher than that because we've had individual ones that were said to be higher, but this was done from the information at a time. And what how we got this, we brought together actual observations. So each of those circles is an observation point, or so a rainfall gauge. So it's bringing together, Gisborne District Council, Hawke's Bay Regional Council, and NIWA gauges. And we did actually also pull in some individual people gauges. And then, so this is over the 3 days, and so obviously most of it sort of fell, over that sort of the 13th of February. But yeah, you're getting sort of more than 500 millimetres of rain in a day, which is just, huge amounts. And in terms of sort of 24-hour return periods, you can sort of see there's some places there where you're looking at, 1 in 300 year rainfall amounts, especially sort of up near Esk Valley and sort of the Horticulture plains, so really intense rain. So we're interested in sort of the flooding. So if you, again, sort of, I'm going to talk mainly sort of based about the Horticulture plains, but we were sort of looking all over Hawkes Bay and also Tairāwhiti. But so the way that we sort of do this, first we sort of need to know where the rivers are, and we have our river network. We're then sort of like, okay, well, where are we actually specifically looking at the flooding? And so for that, we sort of, this is the floodplain, so that sort of fauna area is the floodplain that we're going to do the modelling for. And if we just sort of zoom out a little bit from that, so you can sort of see that same bit of the, is there a pointed bit on this? I don't think there is. But this is just sort of zoomed out, so that black is the catchment, so the whole area that's feeding in, via all of those rivers to that floodplain. So yeah, just sort of outlining there. All of that is sort of feeding in via the different rivers to the floodplain, and then we just sort of, that's the rainfall that actually fell on that. And so with our flood modelling, this is sort of my pretty picture version of it. So yeah, as I said, we take that information where we've got the actual values from the rain gauges. We've also got the values from our modelling of, so that's actually our forecast model. And so what we did is we used the forecast model as sort of a spatial interpolant to work out what happens in between where we have those actual values from the different rain gauges, and use that to adjust it to make out, this is what we think the rain is. That rain went into a hydrological model. So the hydrological model, it's based on different catchments or little sub-catchments, so little bits of the river, and it takes into account the rain that falls, what actually goes into the ground, the different layers, what evaporates back, what flows down the river. And so, you've sort of got that in the catchment, and it flows down the river. And what you get when you get to the sort of the floodplain is you get a hydrograph. So it's telling us how much, in each of the rivers is flowing down into it. And so that's sort of for somewhere up high in the Tūtaikuri catchment. And so, so then the next thing that you really need to know for flood modelling is you need to know what the topography is about. And so we have a DEM, a digital elevation model, which is basically a representation of the ground around you, sort of where it goes up and down. We also have what's called a roughness map, which is the one next to it. And that tells how fast the water moves over the ground. So it's basically, is it, like if it's going over ash melt, it would go a lot faster than if it was going grass, and it would be slower still if it was going through scrub or something that would sort of slow the water down. And so using those in our mathematical models, we basically sort of model the floodwaters as they come over. And so this is sort of, again, for that Horticulture plains. You can sort of see the tide going in and out, and then you've got it coming in, the stock banks breaching and overtopping. You've got that Parko fire where it really, a lot of the breached floodwater all sort of pooled there and was captured by the stock banks, but not able to actually go out because of that. So that's sort of our modelling of what actually sort of happened. And with this, because there were those stock bank breaches, and that was such an important part of it, we did actually model those stock bank breaches, as far as we could work out in terms of the timings. And so we also had some of my colleagues went out and actually did a lot of the measurements, and I mean I was there later, but sort of trying to actually understand what the depths were, capture that information about sort of how deep, how bad. That first picture you can see there, I talk about that as the next place that would have breached if the event had kept on going, because that was what happened for a lot of those breaches. The stock bank was overtopping, and I can't quite see whether you can see it there, but there was a big tree with a trunk about this big that was sort of balanced on top of that stop bank. So you know it wasn't just a little bit of water coming over, it was enough to carry a tree that big. It was scouring, as you can see, that outside edge. In this particular case, the stop bank breached sort of 100 metres down from it, and that probably lowered the water there, so it stopped overtopping here, and so it didn't actually breach there. But that was sort of what happened in that case, and that's, you know, the breaching was caused because, and stop banks, you know, generally are not made to be overtopped. So that's, you know, that's what happens in these situations. But yeah, we sort of used that information just to sort of test our models and sort of, and we did some tweaking. And so this is various sort of assessments of it. So you've got pictures of where the flooding is, and also aerial images where you can sort of see from the coloration, you know, where the flooding actually came. And so they matched quite well. We also used them with the different places where there's actually flood gauges, and in some places the flood gauges remained and we have like the peak of the flood. In many places we actually lost them. If the dots stop, that's because the gauge was taken out by the flooding itself. And so, you know, we don't know whether we exactly got the tops, and I mean, obviously with this, it's our best guesses, so it's not going to be perfect. Also, on the bottom left there was we shared the data with Ngāti Kaununu, and they had all of their information on, you know, from their iwi about who had actually, you know, their houses that were damaged, and they overlaid the information that they had, and they actually sort of said, yeah, no, it seemed to agree quite well with it. And one of the things that this, you know, Cyclone Gabrielle was a terrible thing, but the work from it actually has helped inform something that's come out quite recently, which is our public-facing flood viewer website, where we've got a 1% AEP flood for, you know, all around New Zealand. And so that's sort of what it looks like when you sort of first go into it. That's the blue there is just where we did the modelling, not all the flooding, but sort of if you zoom in, it gives sort of a wrap of information, sort of, you know, what's within that zone in terms of exposure, and it also sort of has the depths for our 1% design storms for all of the different places around New Zealand. And so if you're interested, that's sort of something you can have a look at. It's a national scale viewer, so again, it's not going to be perfect, but in terms of sort of giving some information about, you know, likely places with flood hazard. And also it's got, because there's a lot of, the regional councils also have a lot of information on that. If you go to the regional sort of sectors, like this is the Hawkes Bay region, it's got the links to the Hawkes Bay flooding information as well, and the same for all of the different regional councils. So if there is regional information, you can get that through that as well. But another thing that very much the councils were interested in after the Cyclone Gabrielle was actually understanding its context and sort of the flood frequency analysis. And so we did this work for both, I'm going to talk about Hawkes Bay, we also did some for Tairāwhiti, and there were 20 locations, and they wanted to know, well, what sort of flood was this in terms of the ARI, you know, and so in order to do that, first we needed those peak flow estimates, and so if we had them, that was great, but yeah, if we didn't, we needed to either use our modelling or sort of estimates from looking at how high the floods were and other different things to try and work out, well, what was that actual peak flow? We pulled together the annual maximums from the recorded flows too, so, you know, and some of those records, sort of the longest ones were about 50 or 60 years long, but a lot of them were a lot shorter than that. And in order to try and sort of improve that, we also pulled in the historical records where we actually have them, because there are some records that go back to sort of the late 1800s, early 1900s. And we did these site-specific assessments. And so this is sort of, this is what the Hawkes Bay did with our data. But yeah, if you look, the sort of the green stuff, that's all of the systematic record that they had. So that was sort of, you know, those are the annual maxima, so the biggest flood from each year. And so you can sort of look at that and get a feeling for, oh yeah, that's what we sort of think the flooding is like. And then you look back behind them in the sort of the dark blue colour, and that's the historical floods. So in the past, there have been some pretty big floods sort of in in sort of Hiratonga. This is Puketapu on the Tutaikuri. And so that sort of gives you a feeling of, okay, so what we've seen in that, in the systematic record, isn't as big as you can get. But then, the little, like a little sun up the top, that's Cyclone Gabrielle. So it was, even compared with those sort of historical floods, it was, just huge. And so, they sort of said it's, about the equivalent of 2 Olympic-sized swimming pools passing every second. So that's just a tremendous amount of water. And so in terms of sort of the little red dots there were where we did the assessments. And so some of the places, especially sort of on the Tutaikuri and the Ngorororo, you're looking at sort of, a 1 in 400 year event. And that's including the fact that Cyclone Gabrielle has happened. So it was a really big event. But it's... we don't know sort of what climate change is going to do in terms of, bringing these extratropical cyclones. So, and sort of, we can't rule it out happening again. Some of the other work that happened, and this was sort of in conjunction with the University of Canterbury, was some LiDAR mapping just to sort of, and differencing. And so this is sort of the S Valley here where you're sort of seeing that deposition. So wherever you see blue, that's where there was a lot of deposition, and where you're seeing red is where there was erosion. So this is doing a LiDAR and comparing it with the previous LiDAR. And so, that, and then they're trying to sort of estimate, how much total volume of sediment, was laid down in those areas. And some of the work from that also, again, these are some of my colleagues, Hamish Biggs and Aman Hadidachi, sort of looked at some of that work and were looking at sort of the impacts on bank erosion. And so they were specifically looking at the Awawa Hikuai in Tairāwhiti and the Wairoa River in Hawkes Bay. Sort of, the 220,000 cubic metres of sediment eroded from, sort of 9.1 kilometres of the Awawa Hikuai. And likewise, in the Wairoa River, it's 140,000 in, on sort of the 8.3 kilometres. So that's a huge amount of sediment sort of being eroded away. And probably sort of the take-home was that in places where there was sort of riparian vegetation and that had been retained, generally there was less erosion in those locations. And the only sort of caveat on that was in some places there might be like a big tree or something like that where the entire sort of, it had been eroded away enough that the entire tree came, and in those situations it did sort of, that led to more bank erosion and more bank collapse. So that's sort of, again, that's also an open source paper, so again, if you're interested in looking at that, you can sort of, grab the QR code from that. But yeah, I just sort of was really quickly going through some things there. So yeah, hopefully you enjoyed that, and if you want to know more about it, then feel free to get in touch. But yeah, ngā mihi.